So for this week, we did chi-square, and for the data, we use multiple categorical variables, and we create contingency tables for these variables and use chi-square to determine if there's a relationship between the categorical variables. So Pearson's chi-square compares the observed frequencies in the categories of the data to the expected frequencies that would be expected to occur just by chance. So the test assumes that each participant involved is in only one cell of the contingency table, so there are no repeated measures, and that the expected frequencies of the cells should be greater than 5. So this is because there's a loss of statistical power and the test may fail to detect an effect. So sometimes there are small differences in the cell frequencies, which can result in the statistically significant associations between variables in larger samples. So by looking at row and column percentages, we can interpret the effects, and they will reflect patterns of the data better than the frequencies. So we'll do this later, but because frequencies depend on the sample sizes in the categories themselves. So for my research question, I did 150 employees who were initially hired and trained using online training methods or in-person training, and then a year later they were measured and they were either promoted or they were not. So the data will be used to determine the likelihood of promotion based on the initial training style. And the question is, does the amount of people promoted relate to the type of training used in initial training? So the necessary packages for this were the G models for chi-square, and then sorry, I usually download these before. And then mass for log linear analysis. Okay, so then we load these two. As mentioned before, we have to create a contingency table, so we indicate the values for those who received the online training, and then those who received in-person training, and we bind them together to create the table. So we are entering the data directly into R, creating the two variables, one for each condition, so the online training and the in-person training, and then indicate the two values within each condition, so whether they were not promoted or whether they were promoted. So I did not promoted and then promoted as these two. The resulting columns in this table represent whether the training was done using online training or in-person training, and then the rows show if the participant was promoted versus not promoted. So next, using the cross table, this is for the whole thing. We specifically for the contingency table, because we didn't input raw data, I entered the name of the contingency table data frame, and we can obtain the chi-square tests by adding the chi-square equals true, expected equals true, and the Fisher exact test, true, expected equals true to see the expected values for each cell of the table, and to make sure that the related assumption has been met, so greater than 5, and then S residuals is used to obtain the standardized residuals to look at significant effects, and then we indicate the format as SPSS to display the results. So the output for this contingency table shows us the combination of training, online or in person, the number of participants, the expected frequencies, the chi-squared contributions, and the row proportions, the column proportions, the total proportions, and the standardized residuals, all in this So using that for talking about the different analysis. So the column totals contain the number of cases that fall into each combination of the categories. So we can see that 47 participants were promoted, 31.3% of the total that were trained. Over here. 27 were trained online, which is 54.4% of the total that were promoted, and then 20 were trained in person, which is the 42.6% of the total that were promoted, and then 103 participants were not promoted, which is 68.7% of the total, and then 36 were trained online, which is 35% of the total right here, and then 67 were trained in person, which is 65% of the total. So here. So of those trained online, 42.9% were promoted and 57.1% were not. And of those trained in person, 23% were promoted and 77% were not. So these here. So from the percentages, we can see that online training appeared slightly more likely of predicting later promotion. So we need to check that the assumptions for the chi-square has been met and that all expected frequencies are greater than 5, as mentioned before. So my smallest value was 19.74 for those who received online training and got promoted. So that was my smallest part of the table. So next we're going to look at the output of the chi-square statistics and the significance value to determine if there's an association between the categorical variables, so the type of training and whether the participant was promoted or not. So the chi-square test tests whether the two variables are independent. If the p-value is less than 0.05, then we're going to reject the null hypothesis and the variables are independent. And then so we can gain confidence about their relatedness. So the value of the chi-square for my statistic is 6.70 and the p-value is significant at 0.0096. So these results indicate that the type of training used did have a significant effect on whether the participant was promoted. So the table includes the chi-square contribution for each cell, and if we add these up, they equal the sum of the total for the chi-square. So the Fisher's exact test tells us that the p-value 0.013 indicates that we should reject the null hypothesis as well. And the output also reviews the standardized residuals of each cell for the contingency table, and if the values are greater than 1.96, then the standardized residual is significant. So next we can look at the odds ratio to measure the effect sizes for categorical data. So from that we see that there was a significant association between the type, well, all of that I guess combined, the type of training and whether or not participants were promoted. And this seems to represent the fact that based on the odds ratio, the odds of participants being promoted were higher if they were trained online than if trained in person. So next we are going to do log linear analysis. I created, oh boy, I hope I imported this. Whoops. I usually have this all, good God. Okay, no problem. So for log linear analysis, we're going to add another variable. So I just picked gender. So we can look at gender, training and promotion, gender by training, gender by promotion, training by promotion, gender by training by promotion. So log and linear analysis assumes that a participant falls into one cell of the contingency table once again, so the cells are independent, and the expected frequencies should be large enough for reliable analysis, which just means greater than 1 in this case. So I will input the data. It's already attached, but and then we're going to create separate data frames for males and females. So to do that, pull from that data frame, indicating females and just males. And then we will generate the contingency tables for each, indicating the variables training and promotion. This one. And we want to get this standardized residuals, suppress the proportions using the prop T, and then the column proportions, prop C, and then the chi-square is false, and then so that way they don't appear in the output. So we indicate the standardized residuals, as I said before, and then SPSS. So you got for contingency table for females and then for males. So we can see the proportions for each group in the tables. Different percentages the same way I broke them down above. So next we're going to create a contingency table to put into the function. So to do a log of linear analysis, we enter the contingency table and create a new model with a specified list of variables and the interactions and their predictors, so training and promotion. So starting with females, I will create a table that classifies the cases based on the level of variables of training and promotion. And then I put this into the log lm function to run log linear analysis next. So I'll do this for females, and I also did it for males. So in the saturated model, I indicated training, promotion, and then training by promotion. So training, promotion, training by promotion, pulling the data from that table above. And then I did the same thing with a model without the interaction, so just indicating training and promotion. And then I will run the summaries for these. So the summary of the saturated model shows that the model is not significant, and we're looking to see if the values of the model deviate from observed data. So checking to see for goodness of fit. Non-significance reveals a good fit. So chi-square is 0 and the p-value is 1, indicating that the expected values are the same as the actual data. And then we're going to look at the Pearson chi-square and the p-value in the summary output. So the chi-square here and the p-value, which is not significant. And then we will do I did the same thing for males. So the training by promotion and adding the training by promotion, so that's the saturated model. And then taking away that interaction term. And once again, chi-square is 0 and the p-value is 1, so the expected values are the same as the actual data. And then without the interaction, the chi-square is the 2.92 and then 0.08, so non-significant. So next we will run the mosaic plots to get a kind of visual representation of the data. So we have to install the package VCD. And then library the package. So we create the mosaic plot for the saturated model for the females. And we can see that the size of each rectangle represents the number of females in this case, and the color and boundary of the rectangle tells us about the residual. So a blue residual with solid boundary border. Solid border means the residual is positive, and a red rectangle or a dashed border means the residual is negative. So a rectangle only gets colored if the standardized residual is higher than 2 or lower than -2. So we can see in mine I don't have any color. And then a rectangle, or the standardized residuals are significant if it's approximately higher than 2 or lower than -2. So then the colored ones, the colored rectangles are significant. So more females than expected were promoted when using online training, but the residual is non-significant because the rectangle is white. So fewer females than expected got promoted when using in-person training, indicated by the dotted line, but the residual is also non-significant as the rectangle is still white. So next we do it for the no interaction. So it shows that all the residuals are 0 because they're white boxes with solid boundaries. So the plot shows that it doesn't really matter what sort of training they had the same proportion got promoted in both of the groups. So next we do the same thing for males. So for the saturated model, more males than expected were not promoted when using online training, indicated by the lines, but the residual is non-significant as the rectangle is still white. And while more males got promoted when using in-person training, the residual is also non-significant as the rectangle was white. And then the same thing for no interaction. So as with the females, the mosaic plot of the fitted values for the model without the interaction term for males shows that all the residuals are 0, and they are white because they are the white boxes with the solid borders. And the plot shows it doesn't matter what sort of training the males had, the same proportion got promoted in both groups. So to actually run the log linear analysis, we have to generate a contingency table. So we indicate the original data frame based on the variables gender, training, and promotion. Gender, training, promotion from the log data. And we estimate the saturated model with all the main effects interactions in the contingency table from above. So gender by training by promotion from male-female contingency table. And then we get the summary for that. So then we remove all the three-way interaction terms. We remove the three-way interaction term from the saturated model and create a new model. So we name this three-way. So we update the model from above, removing that interaction. And we get the summary for the output. So we see that the model has a likelihood ratio of 3.46 and with 1 degree of freedom, and p equals 0.06. So next we compare the saturated model to the one without the three-way interaction, so the ANOVA function can calculate the difference between the likelihoods for the two models here. And we can see from this that the p-value for the difference between the models is p equals 0.06. But this is not significant, meaning the three-way interaction is not a significant factor in making the model a good fit, so we have to continue and remove the two-way interactions from the model. So we update the model and remove training and promotion, gender and promotion, and then gender and training. So we can compare these models, the three-way model versus the one with training and promotion removed, which results in a p-value of 0.6. And then the three-way model with gender and promotion removed, which results in a p-value of 0.1. And then the three-way model versus gender and training removed, which results in another value of 0.6. So none of these were significant, didn't have a good fit for the model. So next we will create another mosaic plot. So we can see that the plot shows us the females, that for females they will more likely get promoted when they are trained online, but if you train them in person, they're not more or less likely to get promoted. And then while males are less likely to get promoted when trained online and more likely to get promoted when trained in person. So last we run the chi-square for each gender. So for females, so we can see the chi-square value and the p-value. And then the same thing for males with the chi-square value and the p-value, which I reported in my results. Thanks.